Okay. We have over here in a diagram shown below, the lower block is acted on by a force F, which has a magnitude of 87.2 newtons. The coefficient of kinetic friction between the lower block and the surface is 0.202. The coefficient of kinetic friction between the lower block and the upper block is also 0.202. What is the acceleration of the lower block if the mass of the lower block is 4.8 kilograms and the mass of the upper block is 1.95 kilograms? So what we're going to do is we're going to start by um, getting our variables. So we have m1, which in this case is equal to 4.8. We have m2, which in this case is, oh wait, other way around. This is 4.8, and the upper block is 1.95. Of course, they're in kilograms. And then what you're gonna do is you're gonna also set the force, which you're going to need 87.2 newtons. And then what you're going to do is you're going to set up your equation, okay? Our Fy, I'm going to switch my color. Our Fy, let me scroll down also. Our Fy is going to equal, I'm just going to do the theory of this. The Fy is equal to 0. We do not have any motion in the y-axis. There's only motion in the x-axis. So that's why friction is only available in the x-axis. Our pulley is in the x-axis. The motion, all of it is in the x-axis, okay? Fy is equal to 0. And then our normal force of the second block, N21, is equal to mg. And then we're going to do our Fx, which is going to equal ma, because that is the equation for acceleration. Ma, which is going to equal our tension minus our coefficient of friction, nk, n21. Now, this right here, this part right here, this is just the same thing as saying Fs is equal to mu k n. Okay? We're just making sure that we're subbing in the correct values. And then we're gonna set these equations equal to each other. Sorry, no, we're gonna add them. We are gonna get the equation something like F. Sorry, started off with the wrong area. I'm recording public, so I'm messing up so much. Okay, 2a is equal to F minus mu k, or the coefficient of kinetic friction, m2g, because remember, we have more than one kinetic friction constant and we have more than one force of friction being acted upon this specific equation. So this right here is only one of them. This is for the second block. Then we're going to do minus the mu k, m1g. This is of the first block. And then we're going to do minus mu k, m1g. And isn't that interesting? Okay, we're also going to add tension, but this is because over here, this block has friction in two separate areas. We have friction right here. We have friction right here. And that's why we have to calculate for the friction. So over here, whoops, we are going to use this equation. What else are we going to do? Our force of tension, we know that it is equal to ma, okay, because it is purely in the x-axis. So our next equation is going to look something like, and I'm going to simplify it, m2a is equal to F minus mu k, m2g minus 2 mu k. And I'm doing this because we have 2 mu k values here that we're going to have to add to each other. And then we're going to do m1g. Everything else is the exact same. We're just multiplying the mu k mg by 2 because we have 2 of it. And then our tension force becomes ma minus mu k m1g. Okay? And this is because our tension is mass times acceleration, because we are being pulled, but there's also this force of friction pulling it the other way. Okay? So there's this force of friction works two ways. It works to pull, I'm gonna go back to my my picture here. Let's do it in rainbow, okay? We have a force of friction being pulled this way by M1. We have a force of friction between M1 and M2, and that is going that way because our M1 is going to be sliding in that direction. We have between the M2 and the floor. Because we are being pulled in this direction, we have a kinetic friction going that way. So our value of T cannot only be T, it has to be T minus the friction because we have a force of friction there. So now we're going to rearrange this equation and we are going to get, I just closed my answers. We are going to get, where is it? Okay, 1 second. We're going to get, instead of M2, which is in this case M1 plus M2, because the mass on the second block is always going to be M1 plus M2, we're going to sub in that equation as it is, okay? So this becomes, and it's going to take up more than I have space, it's going to become M1 plus M2, A is equal to, and then we can keep the equation as it is, or we can simplify it, okay? So it becomes F minus mu K mg, sorry, m2g, don't forget that, people, minus 3 mu k m1g, because remember we're combining da da, and we have 2 of this, 1 of this, that becomes 3 altogether. And then we have that, and then we have to do one last step before we can solve, and that makes it equal to A is equal to F minus mu k m2g minus 3 mu k m1g. Make sure you don't mix up the masses, because it does make a difference. And then we are going to divide by m1 plus m2. And that should give you your answer. Make sure you plug in everything, make sure you do order of operations, and that should be your answer.